Can you tell me about what is supervised learning? Is it anyone knows about it? What is supervised learning? You can open the chat as well, or you can open the audio. Then you can say, what is supervised learning? Anyone can, please. This is for the revision, and even we can discuss about the life cycle that in the last Sunday we have discussed about it. I think learning label data. Yes, it is. Can anyone tell me about what is a dependent variable? What is a dependent variable? The prediction values. Okay, means prediction value. If suppose if you want to predict something, and that column is present into that, means your data set we have, and there we have a column like suppose house price prediction is there and price column is there. So price column is, we can call that prediction value, and dependent variable that it is. So just I'm sharing once again the screen here. I'm just which point that I have to tell you that is. I'll take a last Sunday's file as well. Chat is not open. Wait. I have messaged to the group. I think it is taking a little bit time to open. See here. What I want to tell you that in the last session we have worked on the part 2 of this, right? And the major point is that if suppose if I want to go for the prediction purpose, always just think about it. There we have the two types, the regression problems and classification problems, right? So can you tell me about what is a regression? What is a regression? Anyone can, please. What is a regression? You can open the chat as well, or can message me. What is a regression? Because there we, in the machine learning, there we have the three techniques, that supervised, unsupervised, and reinforcement. And we have entered into the supervised learning, and that first part is in that we have discussed about continuous, right? Means regression value. So regression is like a continuous data. Like if you want to predict suppose kind of score, the way you said about predicting a math score, or suppose if you want to predict suppose another one example I would like to give you, weather forecasting, temperature, or another one thing that I want to tell you, predicting house price. So these are the things that comes under the where in the regression. So now we discuss about some problem statement and life cycle as well. So many people's they haven't joined this part two of this one, so maybe you can uh, take your time and please see this one. See the house price prediction that I'm taking here, the part two of the Sunday we have worked on this. Okay, and you know what we have discussed about it, and the problems and pros and cons also we are going to discuss today. Okay, even tomorrow also I'm going to discuss about some logical things related with the regression as well as the classification problem. Within this coming days, within these 2 weeks, we are going to cover up some of the algorithms so that you can easily enter into the prediction part, right? So many people they are thinking about the prediction is a different thing. See, prediction is a different thing, but the process of implementing a data and process of implementing means collection of the data, that is the same, no? So if you go for the analysis, if you go for the prediction, your data is in middle part, means your data is in common thing. If your data is in wrong, then you cannot go for the prediction. The first part you have to do, that is in what, the first part you have to do, that is data pre-processing. If you go for the prediction, if you go for suppose analysis, always just remember that is your data is incorrect or not, right? So maximum whenever you see the implementation of machine learning algorithm, that time always just keep in mind that you have to check your data. And maximum people they are thinking about, just they will take the data and put it down into the machine learning algorithm. So that's the wrong thing. Always go with the data. Check out that. Now I'm just moving forward here, and second, this one. See here, most of the things that we have discussed about posted by, and first, I will discuss about whole process, okay, and then I will go for some problems doing like that. See, uh, I'm taking here one data set here, okay. See, eighth column, the first part that I have taken here, that is house price prediction. And in that house price prediction, I have covered and converted that label encoder. Means label encoder is nothing but your, who is that? Label encoder is nothing but conversion of your string data into the numeric. So label encoder gives always into random categorical values, okay, random categorical values. So let's go for this one. X is equals to dataset dot ilog and colon comma colon 8. Y is equals to dataset dot ilog colon comma -1. So -1 is in your price. And see here we are not doing simple linear regression. Here we are doing multiple linear regression. Okay. So the logic and all, here just I'm implementing the process, but logic and all, the tomorrow session we are going to implement all these things, means regression. And even tomorrow we are going to see about logistic regression as well, because the comparison between the both algorithms, means classification and regression problems we have to discuss about. So today also I will tell you the problem statement, but first we will go for the execution of this code, and then we'll discuss about the problem statement, what kind of problem statement we get here, right? So let's go for this. So check out one thing here. The first, the way we have sliced down the x and y data, do you know why we have to take x and y variable? Can anyone, can anyone tell me about why we have to take x and y variable? Any idea about it? Because your x is an independent variable and y is an dependent variable. So many times just think about it. Is it necessary that I'm asking to you all and try to give the answer? Okay. Is it necessary that in the data set, see what I'm saying? In the data set, is it possible that we can get a more than one dependent variable? Possibilities. If suppose if I'm thinking about I want to predict a BHK number, that is it possible with that? Because now the house price prediction is going on, but I don't want price prediction, I want RERA prediction or the BHK number prediction or BHK or RK prediction. So is it possible that I can take this column as a dependent variable? Not in the multiple linear regression, but is it possible? No, we can go for the classification problem statement, because your RERA is an probability, under construction is an probability, posted by, that is not an probability, that comes under the multi categorial data column. Okay, so think about it, it is possible. So you can take multiple dependent variable, but not in a single algorithm. You can take single dependent variable in a single algorithm only, but you can predict more than one columns with the different algorithms. Now the point is that the way I have sliced down the x and y, just think about it. I have made one structure here. This, see this one. We have the x data, we have the y data as well, and check out the data set call means x dot. Suppose if you make a shape here, see 29,000. Obviously, so if suppose x data has an 29,451, what will be a count of y dot shape? Is it same or different? It is same or different? It's same, no? Right? The 29,451 columns are there. Obviously, there we have that much columns as well, right? And just always keep in mind that one. Always keep in mind. From now, check out next part that we are entering into the from sklearn dot model selection. See what I'm saying? From sklearn dot model selection. Import train test split. Okay. Import train test and split. So model selection is a package and sklearn is my library. Train test split is my class. So can you tell me about why to take a train and test here? Why to take train and test? Why to take train and test? To train the machine and testing. And testing for the test purpose. But is it necessary that we always go for the our own data set? What do you think? Can you can you believe on if suppose if I'm using a custom data means custom test set on the machine, and whatever the answer you are getting, no, is it possible that you are going to believe on that custom data set answers means whatever the output comes? always get a problem. You cannot trust on them directly. But if you are passing your own data set, means if you slice down the data set into the testing set, your own data set, the way we have size we are slicing here, if you pass that, then definitely you can trust. But why? Because your output and your own observations are in front of you, right? But if you create a custom, that is not a part of us, so we have created ourselves, no? That's why we cannot believe on that, but we can believe from the data set that you have sliced down previously. We can use the same data set to the test the output. Yes, it is. We can use, even you can check for the extrain as well. See what I'm saying? It's not necessary to go for the x test as well always. If you pass their extrain, means train data set, if suppose I'm not talking about regression, not only I'm talking about regression, you can think about multi-categorical and binary classification. So why I'm thinking about this, why I'm talking about this, because if you pass extrain and one observation is there that saying that tomorrow will be the rain in the binary classification, probabilistic, tomorrow will be the rain, and you have trained that same data set to the model. See what I'm saying? Same data set to the model, but then also your model is not giving a right answer. Is it correct? So what will be the probability that always your machine gives you the right answer? If you train proper data set, if you train maximum data set to the data observations to the machine, then 101% you can believe on your model, right? So now I'm telling you that there we have the four variables, that is an x train, x test, y train, y test, right? And you know what, actually it's not necessary. See what I'm saying? It is not necessary to create a four variables using train test split. It's not necessary. At the end of the model execution, you have to train the data, no? X train and Y train, it's not necessary to take a same variable names. You can pass the Z, Z1, Z2, Z3, anything name. If suppose your output variables and your input variables are same count, then you can, is it, is that possible? Means completely possible to train your model. Means it's not necessary to go for the train test split straight. If suppose if I created my own data set, if I created my through my own hand, slice down the data and put it down into the extend y train, x test, y test, and I can able to pass here directly extreme y train variable, not needed from this one. If I created it myself only and then train it down. But understanding the machine learning, checking the output, checking the genuineness of your model, then you should go for the train test split model, because you know that you cannot put your data randomly through your own. You cannot pass yourself to random data into the every variable, but train test split gives you to chance to put data randomly into the model. Isn't it correct or not? If I see, if I if I'm discussing about four variables that are necessary to put these four variables into the train test bed. Why? Because he gives the possibilities about testing sign, testing, setting a testing size, setting a random state, so that you can get a randomly values into the four variables. That necessary. But if you create yourself, then definitely get a problem. Obviously we can get a problem. Why? Because you, if you slice down the data, then definitely the data comes directly and sequentially and index based data into the model, and then model is possibilities of model that get biased towards the particular category. Obviously, I'm discussing about the classification problems. Means not only I'm discussing about regression. If you pass the classification problem, then also you will get biased answer. Right? Now, check out the shape and check out the model, linear regression. So I will explain you tomorrow with the PPTs about linear regression, because this one linear regression, logistic regression, all the things tomorrow I'm going to discuss and explain you all the things. Maximum algorithms I'm trying to explain tomorrow only, because once your logic is over, we are going to cover up this point within 2 to 3 sessions only, right? Means all the algorithms. But I'm thinking about, why not we check about this content. So prediction, see, X train and Y train we have trained. Can you tell me about, is it possible that I can pass X and Y variable here instead of passing X train and Y train? Can we pass X and Y only? Means which one data? This one. This. Where it is? This one. X and Y. Is it necessary that we can pass a data into the X and Y? Is it possible? Are you getting my point? What I'm telling to you? I don't want that X train and Y train. I want to pass the X and Y. Then we train all the data set. Yes, it is. It is. See, when it is possible, if you don't want to check your accuracy, first thing. Second, you are believing blindly on your model. Third thing, your problem having same approach towards the multiple domains. Like if you think about credit card has an same approach for the ICICI. Suppose there we have the 10 banks as well, so it's not differentiate. Means there is not a difference that credit card fraud detection has in HDFC Bank has a different credit card frauds, or ICICI has a different credit card frauds, or suppose if you think about World Bank, suppose there we have, and there is a transaction is going on, there is a credit card different frauds, not in like that. So if suppose if I'm training to the model, I'm taking the HDFC Bank's data, and if I train all the crores of data to the single model, so not necessary to, when I go for the ICICI Bank, when I go for the suppose BOB Bank, it's not necessary that I have to train other banks' data to the model. Why? Because credit card fraud detections that problems has an 24 to 28 problems same and predefined problem statement as there. So we can train all the data set from the single, means single domain, means single I say client or something. Means if you take a single client's data and train that, on the basis of that trained data you can go for the multiple. So it's necessary, but it depends upon the means it depends upon the person who is managing these all these factors. Okay, now discuss about y-pred. See, y-pred is equals to r1 dot predict into the bracket. If you think about, there I have added uh, single value. I had a single value like a 2002. So that is a completely one single row. Is it correct? That is completely one single row. R1 is an object. Linear regression is my class. So R1 is an object. Linear regression is class. So just think about, all the data goes into the R1 using the predict method, and all the answer will goes into the y. If if I'm thinking about to add here, see here, actually X test has an how much size and 2900, right? So how much data we got it here? 2900 almost. So if I go for the prediction purpose, you will get and check out the accuracy. What happened? If I want to go for the accuracy checking, you know what I have to do? That is, wait, I'll check for the accuracy score. Mm, if suppose R1 dot, not an R1 actually. There we have some different things as well. I think accuracy score is in between. You have to add X test and Y test, and then definitely you will get in that, right? So check out one thing because I'm little bit confused about code because I have near about 3 to 4 types to check about that. Hmm? I think some is wait. Just give me a second. Hmm. Hmm. We cannot go for this one. Actually, accuracy score between that you have to pass X test and Y test, but that comes under the where that comes under classification. I'm just little bit confused about if suppose if I pass that into the model, what will happen, right? What will happen? So let's go for that. Check out, check out. Mhm. Sometimes it gets easily, but we have worked on it previously. That execution part. Hmm? Wait, I will put here. Mm, accuracy. Something is going wrong here. Wait, I will tell you. score. If check out this one, yeah, this one. I got it. And a little mistake I have done here. See how much output is there, how much percentage we have here. That is only 30% accuracy we got here. So you guys are thinking about how it is possible that we can get only a 30, means we are getting only 30%. Are you getting a point? Why we are taking a 30% of accuracy about a model? Is it possible? Can you believe on the 30% accuracy? See what I'm saying? Can you believe on that? The the accuracy is an primary thing or means secondary? What do you think? I'm asking to you all. If suppose if I'm discussing about accuracy of your model is an primary thing or secondary? Can you believe on accuracy score? Isn't it correct? No. If you are believing that, the point is that you have to believe on your model as well, because yes sir, actually, because you can't believe on your accuracies always. And when you are going to means when that possibilities that you can go for the your accuracy score. See, your data is incorrect. If you are predicting any output and you are applying the x test there, and that is also a correct, means whatever the output of x test we have, that is getting correct output from the prediction value as well. But if you are not getting a single proper answer from the model, then you can't believe on your accuracies. If you are getting a 30% of accuracy, but then also your model is giving a correct output, because you are asking to the x test, that means you are telling to the test x test that ask to the output, and your outputs are correct, then 30% accuracy, 30% your accuracy score also are correct. And it's not necessary always go for the 100%. 100% accuracy is completely wrong. I am thinking about it, because model can't predict all these things. Model can't learn. Isn't it correct? And now think about it. If I'm getting 30% improvisation level, that depends upon the data. Means once again you have to take for the checkout here. I'm just thinking about, why not I pass here to 20%, and random state is equals to unchanging random state. You know that how much data we have, almost 25,000. So I'll pass here 100. So it's not necessary that always we have to pass a 1 2 3 5. You can pass 100 as well, 500 as well, because that depends upon you, that how can you pick the randomized data in the form of means in the form of indexes. Suppose 10th number he is taking, how can you tell them that about 10th numbers, then 5,510th numbers, then 1,110th number. So that is the dependency. It depends upon the random state, how can you pick your data. So now check out what I'm telling to you. Hmm, wait, I'll show you one thing. Have you worked on the data set now? Have you checked once? Yes or no? See, 29. Means the way I'm increasing the count, I'm just passing 40, 60. Check out what will happen. But the way I'm implementing, no, you have to know about observations, means how the observations are changes. If you're going for the interview sessions, you have to tell them each and every point. When I get a 20%, what will be the output? When I pass the 10%, what will be the output? Is that the way, if you are expressing your algorithm, no, implementing algorithm, presenting your algorithm, that time what will be the confidence part about your interview, that they will get to know about how deeply you entered into your algorithm. Only one algorithm you can get your job, means only one, explain your one algorithm and get your job easily. But depends upon the interview what type of questions you will get. Isn't it correct? Now today I'm going to discuss about some of the problem statement here, some of them. Okay, so what I'm going to take here, uh, see, uh, I'll take some of the data set here. So import pandas as a PD. See, this part I'm explaining, that I never explained into the previous day. But for the understanding purpose of your knowledge and algorithm, I'm telling you. And this part also tomorrow I'm going to explain reversely. And with the example, I will take tomorrow. But today I'm explaining you theoretically. Okay. And I'll take a data set here. And the interesting part about the way I'm just going to explain now, you will get to know that what type of problems you will get here, right? And you will also enjoy about it, because now you will get to know that how many types of problem statement you will get in the machine learning. Today I will explain some of them, and tomorrow also I will go for that. Yes, are you there, everyone? Yes or no? Mm, Data set that I'm going to take, that is, I'll take this some different data set here. Salary data, and if suppose if I'm thinking about weather weather station location, weather quality of river, the quality with how the data is looks like. It's very low. I think marketing campaign data set, tokenizing the Python, calling the red. What type of problem we are getting here? But I'll check the data set. See here, what will be the factor here? So the first problem statement we are going to discuss about imbalancing. Okay, imbalancing when it comes into the picture. If suppose if I'm thinking about data set I log, and if I pass here colon comma, um, suppose I'm passing colon and -2. Okay, not necessary that I can pass it whatever you means values. Dataset dot ilog colon comma -1. Okay, so check out, if suppose if I pass here x dot shape 2,84,000. Okay, 2,84,000. Y is equals to y dot shape. You have a 2 negative, same, not an issue. Yeah, imbalancing, that I'm explaining you what kind of imbalancing you will get here. Okay, don't worry sir, I'm just explaining imbalancing. Imbalancing is nothing but if you are going to predict something, suppose here I'm going to predict what. See here, the last column that belongs to the class means your credit card fraud or not. Zero is an true data, means you don't have any fraud there. One, if suppose if you are getting one value in between that, then that is in your fraud data, means fraud transaction is there. Now you don't know that your data, means you don't know that how many frauds and how many true transactions are there. So that what you are going to do, you will go for the data set and check about, see what I'm saying, you go for the data set and check about data set and plus and check about values, value underscore count. See, so zeros has an 2 lakh 84,000 almost, and ones have 492. One is nothing but imbalance, means fraud data. Zero is nothing but true transactions. So now tell me, your data set, it's not in based on the sequential data set, means it's not based on the your zeros column has an first part and your ones column is in one's data, one's transaction are comes under the last of the data set, last position of the data set. All the data is in scrambled manner, no? Isn't it correct or not? All the data is a scrambled manner. Yes. Now tell me, if I split I split my data into the training set and testing set, what is the probability that you are getting a zeros count is in same and ones count is in same into this both point, means where the imbalancing problems comes. First imbalancing problem comes into the actual data set. Actual data set means if you have a data set and if you check a prediction value that is an imbalancing, it looks like an imbalancing. If suppose if you try to train to the model and model is trying to learn something, that both should be a same count, no? Are you getting my point? Means your zeros count is in same and one's count should be a same there. Then your model is learning similar pattern. Then model is capable to give then your model is capable to give proper answer. So actual data set should be in proper. So you guys are thinking about, if suppose once also 492 isn't that much frauds are there, then you guys are thinking about that much we can pass only. If you pass only 492 fraud data, see what I'm saying, if you try pass 492 fraud data, you know what will happen? Model only learn maximum data towards the means about only zeros, means true data. And whenever you ask any question to the model, then always he goes into the bias concept. Model should be biased towards zero. So is it possible? No. Is it, what do you think? The possibilities, the probability of model biasing towards the zero, is it possible? What do you think? Yes or no? Yes, obviously, yes, it bias in the interview sessions. Definitely, more the interview question will come. That is, what is the model biasing? So tell them that if suppose any one of the category has an maximum numbers into the data set, then definitely, if you train your model, that time the model goes into the that favor, means model goes into the maximum number categories are there in that favor, so he goes into the biased concept. So tell them, then definitely the next question will come, so how can you solve that biasing concept? So solving the biasing concept, there we have the imbalancing technique, means solving the imbalancing technique, oversampling, undersampling, smooth texting. So I will tell you that theoretical part as well, because you have to know about what kind of structure we are going to do, what kind of problems we are getting into the model. Model can learn anything, model can give the answer anything, but that is dependency is in our side, that what kind of data you are sharing to training to the model. If you are training wrong data, if you are training imbalancing data to the model, then model is going to give a wrong answer. Model gives you 100% accuracy, but then also you can't believe that accuracy of your model. Why? Because model is always goes into the bias concept. If suppose if you are applying a credit card fraud detection, and maximum time he learns about zeros only, because you have a zeros count how much, 2,84,000, and once data is in 492. If you ask any observation to the model, model goes always into the zeroth position, means always goes into the answer into, if suppose that transaction is in fraud, then also he gives a true transaction. Why? Because he learns only maximum probability into where, zeros. So model biasing concept here comes. Model data imbalancing means model imbalancing, you can say. And solving the model imbalancing, there we have how much ways there we have. First is an undersampling, second oversampling, and third one is an smooth. Smooth is nothing but synthetic oversampling. See what I'm saying, synthetic oversampling. So what is the meaning of all these things? Data imbalancing comes into the model in the data set only. When you take the data set from the client, no, that time you will get a data imbalancing problem. Because if you are going to predict something like suppose in the model, there we have, in model there we have, suppose A, B, C, and that count should be a same, no? See, if I'm thinking about model is in class problem probability, the way we have discussed about the credit card fraud detection, there we have only two categories, that is true and false. Sometimes you will get a multi-categorial system, and multi-categorial also you will get the same problem. Why? Because you have to check about the category count. You have to check that categories value counts as well. If suppose some category are maximum count you are getting, then definitely what will happen? If suppose undersampling and oversampling smart, we are going to work. These are the problem solution techniques to handle minority data or majority data. Are you getting? When the model imbalancing comes, means data imbalancing comes, never still explained you about a cross validation techniques, means what type of problem we are getting. Should we distribute the 492 fraud data equally over the data set? See what I, the question is correct actually. The question is correct. Why I'm just telling you, you cannot distribute your 492 fraud data into the model. I think you can increase the model count. Wait, I will tell you everything. Don't worry. I think I'm visible to you, right? See, I'm I'm explaining you the major point about point that, you know what, if suppose, there we have a major problem. The imbalancing comes when imbalancing comes when your categorical, when your prediction column has in some kind of categories. Can you think about imbalancing problem will come into the regression? What do you think? Can you tell me about that? Your imbalancing problem will come into the regression, continuous value prediction. Is it necessary? Is it possible that this kind of problem statement will get into the regression? How can it is possible that we can get it? um, Imbalancing comes into the categorical concept, no? In the categorical concept, if suppose, if I'm thinking about, if suppose weather forecasting is there, okay, and you want to predict a rain. See what I'm thinking, imbalancing problem is there, and you are thinking about a rain, means rain, how much rain will become, how much, how millimeter rain will come, okay, and rain millimeter is nothing but your continuous data. And this is very rare case that you will get an same value counts there, means 5.0 millimeter, 5.0 millimeter, 5.0 millimeter. If suppose there we have the thousands of rows, very rare cases there we can get a same value of millimeter in observations, that is kind of 10, 10 observations, 10, 20 observations in the regression. But if you think about categorical data, and if you are thinking about credit card fraud detection, match win prediction, that time you will get an 90 to 100% same observations. Even credit card has an 2,85,000. In that also you will get an only 4 500 count of frauds. So you guys are thinking how only that much frauds will get into the credit card? Yes. If suppose, if banks are getting thousands of fraud into a data set, into the credit card, then why they are giving a credit card to the customers? Instead of getting this much frauds, they will stop that whole process. They are satisfied with the frauds, means this much fraud is good. But if I'm getting thousands of frauds, thousands of fraud observations into that, then definitely they will stop this. They will stop the process of this credit cards. So we are trying to reduce frauds. Even we don't want a 492 frauds also. We are trying to reduce that fraud counts. And that time your banks will provide a 2,84,000 of data, and maximum, just see the screen, that there we have the only how much zeros count is in 2,84,000, and ones count is in 492. And bank, if you ask about bank, ask to the bank that you just give me the same count of fraud data, same count of true data, okay, you can't say that one. So what will be the process? What will be the process? You have to increase the count of your fraud data. You have to reduce the count of fraud data. Are you getting my point? The one thing is that the undersampling is nothing but you have to reduce. a maximum majoritical categories into the lower majoritical count, lower majoritical categorical count. If suppose I'm thinking about undersampling, I want to solve the problem. See what I'm saying, I want to solve the problem. This problem comes into the when data set I'm taking from the client, that time this problem will come. Is it correct? No, this problem, when this problem comes, when this problem comes, is it possible to get a business biasness? Okay, sorry, biasness in rain prediction in the summer session. Through the last few days, there was a heavy rain, like extreme value problem. See, you can predict, you can do the assumptions only, means your model can predict, but you cannot believe on that. You can't say, you can't tell, how much data we need, maximum numbers of data and true data we need it. You cannot say like how much data means. You cannot say that like your output isn't correct. You cannot say that if I predict the output, your outputs, your number of outputs will match to your actual data. There we, what, there is a huge number of difference into the actual data, actual output, predicted output, and coming output. Means if suppose I said that your output is saying, your actual data is saying tomorrow is in rain, my data is saying tomorrow will be the rain, but you don't know that what will be the tomorrow's concept. And in the probabilistic, in the multi-categorical way, you can say, but when it comes into the regression, when it comes to the continuous, no, you cannot say anything. You can only tell them that this much rain will come. The data, the rain count, if suppose if you say the 5 millimeter rain will come, your actual value is saying 3 millimeter will come, and you can't predict that tomorrow will be the 500 millimeter rain will be there. So always that, the way you said, always you will get a problem into the prediction. It depends upon, it depends upon the data, it depends upon the client as well, means how much he's satisfying with the output. And the maximum time your your actual output and prediction output is maximum, they are means nearby, that means always it's kind of matchable. Why? You know what, you learn about imbalance, you learn about cross validation technique, everything, that means the way you taking the data set, you go you know that you are going to go for pre-processing things and all, you solve that problems. And then when you take the data set from the client, you go for the data pre-processing, you will go for the data imbalancing, you will go for the cross validation techniques. Means every factor you check about that, then you go for the prediction. And then you think about, this prediction is incorrect, but maximum probability is in your data isn't correct, your output isn't correct, but 90, you can't say that my means my prediction is 100% true. You can tell them, you can say only 99% rain will be there, 1% is depends upon the nature. And you know that sometimes your predictions are completely, means not that much supportive when climate is changed, in comes under the means natural disasters and all. But nowadays all the factors are true, means whole machine learning things, the way Google works, the way the SpaceX, the Elon Musk, the concept they started, the completely predictions are nearby with it, means with the output, right? So just think about it, how much they have trained, how much they trained their models, right? You can't tell that only I will train only 10% of data, 20% of data, but it depends upon how much data you train, how much model, and not only the training the data, how much true data you have trained. The one thing that I want to tell you all, if suppose if I'm thinking about face prediction, means face detection concept, face detection, no, face detection, there is an two classifications there. Computer should learn about two concepts. What kind of two concepts he has to know? If suppose you are thinking about attendance system, the first part comes under, he has to detect only persons, means male and female. No need to predict about, if suppose they're in front of the monkeys or dogs and donkeys or there, then he has to say that he, because if suppose there is a monkey and he has nose, he has lips, he has everything about the chimpanzees have the same face, is it your model is saying that that is a person, you have to go for the, it means he has right to permission about that? Means we have to train our model that first predict about the person and animal, make a difference between the person and animal, and after completion of that, second thing, that person is an Abhay or that person is Amar, Amit, Elon Musk, who is that? Means, are you getting my point what I'm trying to tell you? How the model is going to predict, how the model is getting differentiation between that classifiers, classification problems, isn't it? Can we go for the this different types about this one, undersampling, oversampling, and smooth? Yes. So let's go for one more thing. Data imbalancing, you got the point. Means in the concept you will get that in the data set only you will get that imbalancing. How to overcome that? Undersampling is nothing but undersampling. Samples are nothing but your data observations, and under means you are doing decreasing the maximum count of category. So who is the maximum count of category we have here? Can you tell me who is having the maximum count here? Zeros, no? Is it correct? Yeah. So the undersampling tells you, see what I'm saying? Undersampling tells you, if you want to train your model, see what I'm saying? If you want to train your model, you should make a proper decrement of your count, maximum majoritical count. So majoritical count is in zeros, no? 2,84,000. So the 2,84,000 will reduce till the 492. Means you have to make a count of zeros. How much? 492. So you are going to train your model that 492 of ones, 492 of zeros. Are you getting my point? That is nothing but undersampling, isn't it? Means undersampling means you are decreasing the samples till the minoritical category. So who is a minority category? One. You are reducing the maximum numbers of. See what I'm saying? Yes, 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 yes. Just a minute. Wait, I will pass here. I will pass here some content. Wait. current, see what I'm saying, current data set has an how much, 2 lakh 84 something. Okay, just think about it, 2 lakh 80, and one's having 490. After using undersampling, check out what will be the process. The zeros count is will reduce 492, and one's count is reduced till, means not in reduced, one's count will stay same. Okay, 492, and then this much data you can go and train to the model, because model is, you know that model learns only, means model can learn anything, not an issue, but you have to believe, no, model can learn a same categorical concept. One's also a same count, zeros also a same count. If model learns a same values itself, then possibilities what I'm, are you getting my point, what I'm trying to tell you? Means model is learning equally, so both. So that is nothing but undersampling. Most of the interview sessions, no interview, you will get, and what is undersampling, what is oversampling, and what type of problems we are getting, why to take this one. Yeah, 50-50 means, yeah, you got that point now. 50-50, we have to take that into the consideration when training the model. Yes, it is, you have to consider. See, sometimes learning the algorithm is a different thing, but how much data you are training to your model, that is the matter. If you are training your model 90% of one categorical majoritical count, and 10% is in suppose minoritical count, then model goes into the biasing concept. You have to reduce that count. If suppose model is going to bias, and here your model is giving 100% accuracy, can you believe that model? Yes, you got the point now. Why I'm saying this one, you have to know every factor about it. Only learning of algorithm, that's the completely bad thing. Okay, so oversampling. Now see, oversampling, I'm just changing the sequence of this one, undersampling and oversampling. You know what actually I'm telling you, um, oversampling is nothing but increasing the minority category into the majority. Means how much, you have to increase this count till 84,000, and this count is, and you got the point now. Oversampling is nothing but you are increasing the minoritical data into the majoritical. So you have to remember like this, means undersampling is an undersampling, your majoritical data you are decreasing into the minoritical, and oversampling is nothing but you are increasing the minoritical data into the majoritical count. So this is undersampling, oversampling. Just I'm just doing the sine wave, so you will get to know that one. Hope so. Okay, so sorry. So now one thing we have to discuss about here, I know that you can get that undersampling, oversampling. What is the drawback of oversampling and undersampling? Yeah, are you getting a point? Because the way I'm discussing, no, there we have the some drawbacks. We got a drawback about means means low count of categories and imbalancing problem. That is also a drawback. That's why we have solved this using the undersampling and oversampling. But using undersampling and oversampling also we have the problem. So what kind of problem we have? Undersampling also, see, undersampling tells you reduce the count of majoritical category into the minoritical category. Yes, yes, yes. You guys are saying same. Isn't it that the missing with the real data distribution has a prediction? I mean, regardless, the fact is that they imbalance. Yeah, yeah, they are imbalanced. That's what happened in the reality. There isn't more chances to have a zero to have one. Yeah, undersampling we have to remove some data, but oversampling should have to create a data or increase the data sample. Yes, that is the point. No, that is the thing that I want to tell you, isn't it? Yeah, actually, if in the undersampling you are decreasing your actual, you are losing your zeros count data, means 2,84,000 data you are decreasing into where 492. Even you don't know that how can you get that, means randomly pick up in the data or not, or directly you are slicing the data and put it down into the 492 to the model, and you are, see, it's not, I'm just telling you 492 and means zeros count 492, ones count 492, you are training to your model. Is it possible that you are believing on that model? Why? Because you are reducing your count, zeros count. Can you believe? Your samples? Yeah, artificial data. See, this is not an artificial data. That's the wrong, means we are not passing artificial data, you are passing actual data. Only you are taking 492 from them, means it's kind of taking a samples from the population. The way, if suppose group of populations are there, you are taking the advice of some of the peoples that my transaction isn't fraud or not, isn't it? You know the opinion polls kind of concept. Crores of peoples are there, but you are taking opinion of only few peoples, and on the basis of few peoples you are saying that your transaction is true or not. Exactly. You got the point now, guys. See now, uh now I'm just want to tell you, see the way we have reduced, zeros count is reduced, means zeros data we lost. When we come under the oversampling, when we comes under the oversampling, you are increasing the count of what? One's data. So how much count will increase? 492 to 2,84,000. Just imagine. So you guys are thinking about how that data is increased, because that data is in only that much. Now the data is increased randomly. Duplication of data comes. Redundancy it comes. If redundancy is comes, your model is trying to give the answer same to all towards the redundant data. Model goes biased towards what? Ones. Is it correct what I'm trying to tell you? You are creating a duplication of huge amount of data. Model goes that biasing concept. Model goes double biasing towards that model, towards that category. You guys are thinking about, you are telling us a problem solution technique or problem increasing technique. See, here you are not solving the problems of prediction, you are solving the imbalancing problem. You are not solving the prediction problem. You are solving the imbalancing problem. Data model says you, please give me what? Balanced categories. That's why you are passing a balanced categories. Model not telling you that I'm giving a wrong answer to you. Model is only capable that how much you train, that much he gives the answer. Are you getting my point what I'm trying to tell you? Now the point is that I'm just uh, the way you say that undersampling, oversampling, there we have another one, that is an smart technique. What kind of technique we have? Smart. Smart is nothing but synthetic oversampling. What? Synthetic oversampling technique. Let's disclose this one as well, because you know that once you get this one, definitely you will not miss, you will not forget this one once I teach you about this one. My spell is correct? Synthetic. Actually, this problem will get into the, you know, synthetic. Yeah, my spell is this one. Synthetic samples. So smart is nothing but a synthetic oversampling technique. So what is the meaning of synthetic? The way just before someone says that artificial, someone says that, are you getting my point? Artificial is nothing but you are creating artificial data. You are not making a duplication of data, you are creating artificial data, isn't it? Are you getting my point? You are not making a duplication of your own data set, you are creating artificial data to the way artificial rain created, no? The similar way you can think about this one also. Artificial data increasing means, suppose oversampling, or the way, what is the name of this proper smart technique? Synthetic oversampling. So what is the oversampling? What I had, what already I told you? Increasing the oversampling, increasing the count. Oversampling is nothing but increasing the count. Oversampling. Undersampling is decreasing. So you are increasing the count. So which increasing the count? You have the minority, no? See what I'm saying? You have minority. So if you have minoritical categories, you are increasing the minoritical category to the majoritical category. This problems comes under the multi-class problem, where there is an prediction column, and that column is having, see what I'm saying? That column is having multi-class categories. That column is having multi-class categories, and in that multi-class categories you are having how much problem? Minority problem, imbalancing problem in between the multi-class categories. Means, suppose if you are having a b c d categories and you are not having a similar equal count, in that also you will get a problem, isn't it? Yes or no? What do you think? Means this problem will increase your headache. 101% when you go for the implementation of classification problem statement. You always, you, if suppose if you pass down, the within a 5 minutes you will solve the problem, means prediction stages, you will go for the prediction, that's all, that's all, that's all. But the point is that, can you believe on your model? And if you think about, if you discuss about this, means if you think about which algorithm I have to use, and your interview will ask you about which algorithm you used in your problem statement. You say that I used a classification problem statement with the logistic regression or KNN, and your interview will ask which algorithm is best. And if you say KNN is the best, when you say KNN is the best, that time your interview will say go outside first, because you can't say that algorithm is best, that algorithm is best, that algorithm is best, or that algorithm is bad. Why? Because your whole process is based on your data. Your data isn't bad, you can't say your algorithm is bad. Are you getting my point? If your data is imbalanced, your data is having a raw problem, your data is in complete not pre-processed technique, then definitely the whole problem statement comes under the pre-process, means whole problem is yours, not an algorithms. Okay, so now the way I told you about smart is increasing the your minoritical, means say, see, there we have two. See, the count is looks like this one: 2,84,000, 2 lakh, 2,24,000, 2,04,000 kind of things. If I try to learn about that to the model, total count of your model is nothing but like 8 lakh something, means 8 to 9 lakh something, and you will try to go for the training to the model. But model, that model is get biased towards the majoritical category. So if you want to reduce that, you will go for the synthetic oversampling. Synthetic oversampling, what he will do, who is the majoritical count here? Zeros has a majoritical count, means maximum majority. And what is the next process he is going to do? One's count will increase till zeros count, two's count will till increase zeros count, three's count will till increase zeros count, and then he will go for the training purpose. He is increasing the count of minoritical till, means as a artificially. And once he increase the count artificially, that's it, you'll go for the prediction purpose. Now you guys thinking about, is here also comes imbalancing biasing concept after the solving the sample, means after solving the imbalancing problem? Yes. What is the problem that you will get here? What will be the new count here? Almost you will get an 9 lakh, 9 lakh 2,000 maybe, because 2 into 4 and almost 9 lakh 80, 9 lakh 2,000 maybe. Yes. So just imagine, the way you are using a sampling techniques, you will increase the count, model will get run, not an issue. 9 lakh 12,000 maybe. Yeah, everyone till the, yes, everyone. This, yes, that count will be increased till, if suppose 2 lakh 4,000 is there, that will be till increased 2 lakh 84,000. That's correct, sir. That's correct. So I thought I'm discussing about total count. So just imagine, it's not only this problem. Just think about, if I'm going to train our model, I'm coming to the this problem now. See, now I want to tell you one major point. See, not an issue, you solve the problem, you solve the majoritical problem with the oversampling, undersampling and synthetic. Means now you are giving to the model equal data. That's it. Everyone is now ready to discuss last point of the this one. Yes, you are giving to the model that equal count. Now take the one point here. I'm coming to the this point here. You know this stage, everyone knows this stage. What is the use of this stage? Training and testing model. Can you check this point here? Test size is in zero point 0.4 and random state is equals to 100. Yes. What is the possibilities that you will not get here imbalancing problem once again? What is the possibilities? Can you tell me the yes or no? Here also we are, is it possible that we can get here imbalancing problem once again here? Not in the first stage we got that problem and we solved, we passed equal data to the model. Now now the data is equally having here x and y's data, we have equal data here and passed here x and y. We are going to divide your data x and y into the four variables. And here you have said that point four is nothing but 60/40, means 60 is data into the training set and 40% data into the testing set. And you said that random state is equals to 100. Why not possibilities that your data goes into the imbalancing once again? Why? Because you are picking up a randomly, you are picking up a data randomly. Why why there is an possibilities that x train gets maximum numbers of zeros, x trace get maximum numbers of ones? Are you getting my point, guys? That's the machine learning, no? Actually, many people's, many of the peoples, they get stuck in the machine learning stuff here. Many people think about machine learning within a same concept we can solve problems. No, actually, think about it. Everyone, please concentrate on the screen. Till here, till here, I solved my problem, that I discussed, I made solution that here also I will get an 1 lakh zeros count is 1 lakh 84,000, and ones count also 2 lakh 84,000. That's the correct thing, no? We solve that problem, not an issue. We are going to train our model. And now now your xy data sliced down into the equally, not an issue. Your y is nothing but prediction value, means this is 0 and 1. But the way you are passing into the xy, your data is going to slice down into the 4, no, randomly data. You are picking up a randomly data. So you are taking randomly into the x train, x test. Means do not think about x train and x test. Think about y train and y test. You already made equal data, but when I pass into the train test plate, that equal data also slice down into the x train and y train. Y train and this one, x train and y test. So what is the possibilities that you are passing equal data to y-train and y-test? See, the way I said, this is an 40%, this is an 60%. Is it correct? Yes, that's the point, sir. That's the point I'm telling you. This for a problem statement, and you are picking up a randomly into the y-train and y-test, no, so definitely you will get a problem. And this problem also we have to solve, and this problem statement we have to call cross validation techniques. What? Cross validation techniques. The first part, before the training testing fleet, we got in which problem statement? Data imbalancing. And when we go for the model slicing, means train test split time, creating a test set and train set, that time we are getting cross validation techniques. There we have a types of cross validation technique. Now got the point? Yeah, that's the great thing. Actually, you know what, I'm just trying to give you some of the practical things. But before that, we have to discuss about this kind of problem statement. You know, only executing the programs, you will get a many codes into the internet. But we are not acting about like that. We have to face every problematic things, because once you learn one algorithm properly, that is easiest thing, you can solve the 10 to 15 problem statement and other algorithms easily. So we can put our maximum time to solve the proper way to proper ways about algorithmic process, taking the dataset from the end till the end, right? So I think today, whatever the things that I have discussed, I think I'm thinking about you got the all the points, right? In coming sessions also, we can do the practical things about this imbalancing and cross validation techniques. Why I have said this kind of structure? Because you should change your mindset towards the data. If your data is correct, your prediction is correct. If your data is wrong, then prediction is completely wrong. Got the point? You think about, I'm passing the wrong data, but it's okay, I can predict the output and I will get the 100%. Just think about it. If you are passing wrong data and you know that you have a wrong data to, means you have passed wrong data to the model, do not believe on the prediction. Do not believe. It's kind of child, no? If you're trained wrongly into to the your child, then he reflect wrong. That's the same thing that comes under the machine learning. That is a machine. Hope you got today's point, guys, and enjoyed as well. And when we come tomorrow, we'll do the more interactive session, and definitely will enjoy. Yes. Yeah, thank you so much, sir. I appreciate. So let's come tomorrow session. Till then, enjoy. Thank you so much. Thank you, ma'am. Thank you. Thank you. See you.